Salam sejahtera, I am Chukaisen. Now, I would like to present the design thinking methodology. For the phase 1, empathize, the baby have limited capacity for thermal regulation. It is because baby lost the heat easier than the adult, and the baby will overheat easily and they do not sweat efficiently. Overheat is a risk factor for sudden infant death syndrome. So nowadays, most of the parents use the menu blanket for the babies, but it requires the constant intervention and it leads to the parent sleep deprivation and anxiety. So they need to always wake up and check for the conditioned baby. Next, for the phase 2 is defined. Our problem level is that current solutions are lack automated safely. So there is not integrated system to safely maintain optimal thermal condition and causing health death risk and parent stress. Our objective is to develop a prototype with a feedback control system for precise regulation and advanced safety for overheat protection. So in our scope, we use the ESP32 integration with the temperature sensor, movement sensor, and moisture sensor. After that, we use Wi-Fi connectivity for the real-time monitoring by using the blink.
Okay, today I want to continue for the step analysis. For the phase 3, we get the ideate. We get the five ideate for the step analysis. For the first one is social, technological, economical, environmental, and political. For the first one is smart heated air blanket to ensure babies for the comfortable, and then the real-time temperature for the monitoring. And technological is IoT and the temperature sensor for the monitoring, and then the automatic temperature regulation to prevent overheating. And then for the economy of affordable smart blanket, and then reducing medical expenses by the cold little illness for the babies. And then environmental is low power heating environment, and then eco-friendly. Political is designed to comply with the child safety, and then support healthcare for the infant care safety.
So for the phase of prototype, our main core is it can precisely control the thermal for its stability. So if it exceeds 38 degrees Celsius, it will send the emergency alert notification, and also it will automatically drop the temperatures by 2 degrees Celsius to prevent sweating if detect 20 minutes of illness. And also the steam curve is for prevent the steam burn for detect wetness. So for this phase of test validation, our main core is safety. It will immediately cut off the heater to prevent the burn risk. For the health, we will prevent the overheating for the deep sleep logic implementation. The early detection for the non-abnormal heat when the heater is inactive, and lastly for the user centeredness to address the parental sleep deprivation and anxiety.
Here is our costing. Our total cost is 195 ringgit 9 cents.
For this demonstration, I'll show you how the code manage the blankets logic. I've set the target temperature to 32 degrees on the Blink app. You can see the live temperature and battery data streaming in. By using the booster, we ensure the 5-volt heating pad gets a consistent power without dropping the ESP32's voltage during the heat cycle.
Now, watch the deep sleep logic. I've set a 60-second test window for this demo. Since the accelerometer hasn't detected movement, the system automatically drops the target temperature. Here is the notification on my phone. Deep sleep detected, lowering temperature 2 degrees Celsius. This confirms the software is successfully adjusting comfort level based on the baby's state. Now, watch the deep sleep logic. I've set a 60-second test window for this demo. Since the accelerometer hasn't detected movement, the system automatically drops the target temperature. Here is the notification on my phone. Deep sleep detected, lowering temperature 2 degrees Celsius. This confirms the software is successfully adjusting comfort level based on the baby's state. Now see, if the temperature crosses 38 degrees, it triggers the alert. High body temperature detected. Check baby. While this is a prototype and still needs calibration for real-world environmental noise, the logic proves we can turn a standard blanket into an active safety device. Thank you.
Finally, to summarize our entire smart heater blanket project, our blanket has an automatic heating control that regulates the blanket's overall temperature, which helps babies to maintain a constant warmth to a safe level. It will stay the same in multiple scenarios such as cold weather or a rainy day. Next, with extra precaution steps in place, it helps to reduce burns and electrical risk to babies when the blanket is in use, such as avoiding going over temperature or shutting down to avoid sudden shock. With our Internet of Things integration with Wi-Fi connectivity to a user's phone, parents can easily monitor the blanket's heating more easily and efficiently. They only have to check their smartphone to adjust or turn off the blanket from a distance. Finally, this project also attempts to help families to save time and money for the best childcare they can afford for their babies. A simple heating blanket like this can save money from their medical expenses.